Welcome, everyone. 2 weeks ago, Joe gave an introduction to all the new features in the latest version of Apl64. In today's session, we will focus on the Quad-RNET system function. Quad-RNET is Apl64's .NET interface to the R statistical and graphics toolkit. Some of you might already be very familiar with the R language and its toolkit. R provides a wide variety of statistical and graphical techniques, including linear, nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, etc. R is highly extensible to installable packages. R enables users to perform data manipulation and calculation and produce publication quality plots. R is available as free software under the terms of Free Software Foundation's GNU General Public License. R can run on a variety of platforms, including Windows, Mac OS, and Linux. Developers and users can download R installers from the middle size of the comprehensive R archive network. It may be necessary to run R installer as an administrator. The default configurations of the R installers are usually sufficient. And you can see here's a screen capture of the R installer for the Windows. The Apl64 system function RNET is a .NET interface to the R statistical and graphic toolkit. Quad-RNET is cross-platform, provided an appropriate version of the R for the target operating system is installed. There's only one instance of R engine when using the Quad-RNET in an instance of Apl64. The R engine is automatically disposed of when Apl64 instance ends. Quad-RNET is available in a developer and runtime version of Apl64. To initialize the R engine, we can call the Quad-RNET init R action. Init R action doesn't return any R instance because there's only one instance of R engine. We're using the Quad-RNET in an instance of Apl64. And the R engine is automatically disposed of when the instance ends. This action must be used once in the Apl64 instance before any other Quad-RNET actions are used. The argument to the init R action is the path to the R executable. Here's a typical example. Please note that on the Windows, R typically finds its executable and dynamic link libraries through the path environment variable. When the R executable path is added to the Windows path environment variable, the init R action doesn't require a full path as its argument. I'm going to show the page here. And you can see this is my environment variable dialog box. And if I open up the path, you can see I added the path to the R executable to my path environment variable. So I'm going to cancel here. And let's bring up the Apl64 instance. So when I add the path to my path environment variable, I don't need to specify the full path, and I can just do this. And so we can try a couple of simple examples. If we want to find out the current version of R, you can try this. You can see the latest version that's available is 4.5.2. And we can see where it's being stored. So it's being stored in my C drive, the program file. And if we want to see the one, say for example, the library, where the libraries are stored. Oh, sorry. I forgot using the get action. Let's get the library path. And if we want to see current working directory, this is my working directory. And if we want to see some system information, we can try this. Sorry. Yep, that's it. So you can see there's some system information being returned. And one of the most often used actions of the Quad RNet is called evaluate, or we can use eval as well. The evaluate action will cause the R engine to evaluate a single line or multi-line script within the R environment. Evaluate returns no result. To obtain the result of the R expression, you can assign that to an R variable and use the Quad RNet get action to obtain the result in the Apl64. Please know that some of the R data types have no representation in APL. And we can try an example. Sorry, I mean to use the evaluate. Sorry. Yeah. Then you can do. Yeah. As you get can achieve very often get can achieve the same expected behavior. So, but let's focus on the evaluate first. Okay, to evaluate a multi-line script, we can use the APL variable editor, for example. So I'm going to open up the variable editor. Use the same example. And we can do, say, for example, we make something simple. So we're going to divide the sum by 2. And if we save this, let's save it A. So we have created a variable, a multi-line variable called A. So backing our session by Quad RNet to eval A. And then we get RNet. We can call get. It should be 4 as expected. We can also define a multi-line string variable to, so I'm going to close this. I'm going to use a function editor this time. So my function called S, I call test. I have a localized variable S. So this is the multi-line string variable. Fine. This time we're going to double the sum. Like that, and then we're going to eval. And then let's go get some. All right, we're going to save our little function here. And now let's run the RNET. Run our test function. So you can see the sum now is 16, as expected. There's another way you can join multiple R statements using a semicolon. I'm going to show that here. Let's try rebound. And again, this is sum, for example, 3 plus 5. And then we say sum, this will be sum, 5, another 1, sum equal to 7 divided by 2. Okay. So now we say RNET, get the sum. So you can see, so 8 times 5, and then divided by 2, so that's 20. All right. And next, I'm going to show that the RNET also supports value substitution and Unicode characters. I'm going to bring up my test workspace. Okay. So I have an example here. So here is my value substitution. You can see we substitute 1, 2, 3 into the first spot here, first index, and then ABC into the second index, and then some Unicode characters into the third spot. I'm going to run this function. So you can see the output is in capture 1, 2, 3 ABC, and some Unicode characters, pi, and yeah, some of those characters. So for more detailed information about the value substitution, you can refer to the user documentation. So now I'm going to minimize this. So within an APL multi-line script, it's possible to temporarily transfer evaluation control from the R environment to the Apl64 environment. This is accomplished by adding an APL colon prefix to an APL statement within a multi-line R script. Let's take an example. This is the multi-line script, and you can see within this script there's a number. There's 2 or 3. There's 3 statements that begins with the APL colon. Here, here, and then here. So this allows the RNET to make a switch from the R environment back to the Apl64 context. And once that statement is completed, and then when that returns, the RNET will continue its execution of the remaining and the following statements. And just because the RNET doesn't know how to handle the APL specific statements, it has no idea what how to process this or even a RNET. So we're gonna try this example. So this is a simple example, returns the square loop and the Q loop of the given argument. So we're gonna try this. So if we pass in 2, we should see that it executes the APL statement, for example, the quad-sys verb, the current version of the Apl64, and then it sets the variable through the RNET, and then it processes the R expression, and then eventually it retrieves those results. So, and next we're going to talk about how to use our engine for the ad hoc calculations. So let me bring up another example. That's somewhere. Cool. So this is one I'm going to show to everybody. In this example, the input value, the radius, is provided to the R engine and used to calculate the area of the circle. And then using the R engine's set symbol, evaluate, and get symbol action. So I'm going to try this. We're going to try a unit circle with the radius 1. You can see as expected the area is pi. And then here's another example demonstrating the use of the quad RNET get action with value substitution. This is another example. Here, you can see the argument radius get passed into the value substitution. So we're going to try this one. Just has some numbers. So you can see it returns the area of the circle. Next, we're going to talk about the how quad RNET conducts a two-symbol t-test with given input. In t-test, we compare the means of two independent symbols and do not assume the equal variance between the symbols. So let me see again. So the test function. So this is the example that shows how quad RNET performs the t-test. We have two groups or two symbol values, and we're going to try this. I think we can just call it t-test. So you can see without assuming the equal variance, so this is the result. And if we want to tell the R to assume equal variance between two symbols, we can make a small changes here. This is called R dot equal to 2. So like this. Okay. If we run the same function again, you can see there's a difference here now in terms of the output. So this time it doesn't assume equal variance between the two symbols. Next, we're going to try another statistical function. This time it's the ANOVA. Let's try a function. Bring up the ANOVA function. So this is the little test function. And please note that the results may vary because the symbols used, this particular example used the normal distribution symbols. So we're going to run this function ANOVA. So this is the output. Next, we're going to talk about the R packages. R packages are a collection of R functions, compiled code, and symbol data. They are typically stored under a directory called library in the R environment. By default, R installs a set of packages during installation. More packages can be added later when needed. When we start R engine, only the default packages are available. Other packages that are already installed must be loaded explicitly for the R programs that need them. Okay, to add a new R package, we can download and install it from the comprehensive R archive network. When downloading an R package, we can choose a Miller site appropriate to our location. Installing an R package may require administrator privileges. Let's try an example. This is a simple example function that I created. It's try to download and install and load a package called the Stringy. The Stringy package provides fast, portable, consistent, and convenient strings for text processing across any locale or character encoding. So I'm going to try running this example. So this brings up a comprehensive R archive network Miller site. So for me, I'm going to choose this location. I'm going to try if we can download it. So download it and put it into the library in my R environment. And if we want to see already installed package, we can. This is a little test function I created. So it should generate some list. List. So those are the packages that are currently installed in my system, and you can check out this string package we just downloaded. It's right here. So. All right. Next, we will talk about the R data frame. Data frames are the fundamental data structures in R. R relies on data reshaping to change the way data is organized into rows and columns. The core RNET actions to create a data frame is called the create data frame, or CDF, which takes an Apl64 matrix. The Apl64 programmer can optionally supply row and column names. If rows and column names are not supplied, they will be created by the create data frame action by default. Let's take a look at the example. The simple data frame. You can see the action for CDF. And we create a data frame called DF1, and then we provide the matrix and some additional arguments. So let's run this. And as you can see, this is the APO SQL matrix, and this is the data frame that we created. Okay, in the next example, this example demonstrates that we supply, as a programmer, we supply the column names and row names. to the CDF action. So let's try this. One. So you can see the unit cost here. Yeah, those are and the product 1, 2, 3, 4, 5. They're all here. And in the third example, we're gonna show the how we can set the row names and column names separately. So you can see we create a data frame first, and then we can set the column names and row names. So let's do this. So you can see after we set the column names and row names, they are displayed here. And please know that in Apl64 qua RNET, the Unicode characters can be used in the columns and row names. There's another action, another create data frame action, which takes a nested matrix and creates a data frame. I'm not going to get into the details. You can refer to the user documentation. I did create editable example for the documentation. I can show it here. So this one, and you can see this particular action is called the CDF NM. So that takes a nested matrix. We can run this one as well. Action. Next, we're going to talk about the qua RNET plot action. We're going to start with an example. Function called plot1. It generates a PNG file. We pass the target file path, target file type, the command script, the image width, height, and resolution to the plot action. So we can run this. We temporarily exit from here because we're going to send the output file to my desktop. So I'm going to try this one. Okay, you can see it now on my desktop. If I double click the image, so this is the plot that generated by our plot1 function. With the width, height, and resolution, the type of the output file, and then the path. So we're going to try another example, and this time it displays the R plot in the qua waveform. So let's take a look at the example. And you can see that it creates a form, qua waveform, and then it plays the plot in the in the form. So let's run it. Okay, so you can see this is our plot here. Okay, all right. So next we're gonna explore the R plotting capability using random data. And let's take a look at another example. Okay, so this is our example here. Uh, this example will generate the R plot that there will be two R plots overlaid in the same chart. The first is the histogram symbol average values, and the second is a line chart of the same average values, illustrating the anticipated observation of the central limit theorem. All right, so we're going to try this. The pseudo-random trial values are generated using Apl64 random number generator. In a production environment, the trial values would come from a simulation or experiment. And we can run this example a few more times, and because it's relied on the random number generator, the result will be different each time. So we're going to try this a couple more times. So you can see. Okay. All right. In the next example, we will use R-plot to do the beta distribution. The beta distribution has two parameters, alpha and beta, which provide flexibility to specify a symmetric probability distribution. Let me bring up the example. You can see there's a function called the I think it's called the R beta right here. The R beta function is used to generate n symbol values for a beta distributed random variable and display the plot in the Apl64. So we're going to test this. All right, so this is our output. Okay. Okay, so back in our point. Please note that the gplot2 is simple to use in quad RNET. There's no gplot2 action being created. The typical gplot2 workflow involves using quad RNET eval or set actions to pass Apl64 data to the R instance. If desired, use the quad RNET eval or set action to assign the gplot2 result to an R variable using the quad RNET eval action to run R function gsave to render the gplot2 to a file in a desired format, dimensions, and file type. The file-based result of gplot2 can be included in an Apl64 quad-wave form using the quad-wave picture or BMP feature, the bitmap feature. Let's try an example. example, this one here. Okay, so this is the output. Minus here. All right. So, all right. Next, we're going to talk, actually, lastly, we're going to talk about the quad RNet error handling. It's recommended to validate Apl64 input sent to the R environment for processing and use a try-catch construct to handle potential exceptions. Okay. To view the quad RNet documentation summary, you can execute quad RNet with the question mark. So those are the key, those are all the actions that's currently supported. So, and here's some resource. If anyone interested, you can explore some of those websites, and you can also do some using the search engine to find more if you want. Okay. So, yeah, I guess this concludes my presentation today. Then we now can open up to questions, comments, suggestions.